Hi, we will wait for 5 to 10 minutes. No, we will wait up to 6:04 until the other students join. Then we will start today's class. Yeah, we'll start today's class now. Yeah, I think all of you got a mail regarding the exams, right? It's pen and paper exam. So whether someone told they will inquire about that, which I think Dr. Manchu. Oh, I think she's not here today. Okay, it's a pen and paper based exam, so I also got a mail today since I joined that group as a student. So I hopefully it will be directly things coming from exams. So we'll start today's class. So we'll initially try to solve last week's assignments. So we'll start from the question. If the concentration is increased by 16 times the original value, then equivalent conductance for a strong electrolyte will increase by uh, apply hmm, I think it's a straightforward question. So what will be the answer? 1 second, I am not being. Hello? Yeah. What will be the answer? Again, we solve it. I think I have solved a similar problem in last class. We have the equation lambda c is equal to lambda 0 minus b root c. Suppose initial concentration is C1. It is given that then after changing concentration it's C2. C1 is equal to 16 C2. So C1 I will take it as C so that uh, you can write like that lambda C1 is equal to lambda 0 minus b root c. For lambda C2 is equal to lambda 0 minus b root 16c, which will be equal to lambda 0 minus 4b root c. So taking mode lambda c2 minus lambda c1, you will get 3b root c. Just straightforward. Since we solved in the last class, I think you are able to solve this problem in the assignments. Is there any doubt in that? So we'll move on to next question. Given question number 2, at 298 Kelvin, the equivalent conductance of zero point 0.1 normal CH3 COOH is 3.2 Siemens centimeter square per gram equivalent. The equivalent conductance at infinite dilution is 290.9 Siemens centimeter square per gram. The dissociation constant for acetic acid at 298 Kelvin. Mhm. How can we calculate? What is the formula we have to use for dissociation constant? What formula we'll use? K alpha is equal to What will be the formula? Anyone? You have to remember these formulas. It is lambda c square into concentration divided by lambda 0 into lambda 0 minus lambda c. So what all value is given? Lambda c is equal to 3.2 Siemens centimeter square per gram equivalent. Then lambda 0 is also given. Lambda 0 is equal to 290.9 Siemens centimeter squares per gram equivalent. Then C is given 0.1 normal. So we can directly calculate what will be the value of K alpha. I think you all solved it for homework, right? Assignment. So what will be the value? K alpha. Did you all solve this problem for homework? Homework 6, assignment 6. Yeah, 1.22. So how it will be 3.2 into square into 0.1 divided by 290.9 into 290.9 minus 3.2. So it will be coming, that numerator will be coming, which will be equal to 1.024 divided by 83691.93. So the answer will be 1.224 into 10 raised to minus 5. So next question, we will do it as a practice one. So the question is lambda 0 H2O. Lambda 0 I will write as in the superscript because it is easy for representing water. So is equal to, so I'm given with a number of options. 1 lambda 0 HCl minus lambda 0 NaOH minus lambda 0 NaCl. Second option is lambda 0 HNO3 minus plus lambda 0, what is that? NaNO3 minus lambda 0 NaOH. Then third option is lambda 0 HNO3 plus lambda 0 NaOH minus lambda 0 NaNO3. Fourth option is lambda 0 NaOH, oh sorry, NH4OH, lambda 0 NH4OH plus lambda 0 HCl minus, what is it, lambda 0 NH4Cl. So first one we will just do here, then I'll see how you all approach it. So first one is lambda 0 HCl plus lambda 0 NaOH minus lambda 0 NaCl. How can I write it? It is equal to L0H plus L0Cl minus plus L0Na plus L0NaOH minus L0Na plus minus L0Cl minus. So this Cl minus cancels out. This Na plus cancels out, which is equal to L0H plus L0OH minus, which is nothing but lambda 0 H2O. So which is same as lambda 0 H2O. So now you take the second one, lambda 0 HNO3 plus lambda 0 NaNO3 minus lambda 0 NaOH. How can you write it? Any of you? How can I write in terms of ionic conductivity? How can I write lambda 0 HNO3? Anyone? How can I write it? Lambda 0 HNO3 is equal to, yeah, L0 H plus L0. It is, we have to write equivalent conductance in terms of ionic conductivity. Yeah, L0 H plus L0 NO3 minus. So similarly, how can I write lambda 0 NaNO3? How can I write? L0 Na plus L0 NO3 minus. Then minus L0 Na plus minus L0 OH minus. So here Na plus NH plus cancel out, but NO3 is not cancelling out. So you can see which is L0 H plus minus L0 OH minus plus 2 L0 NO3 minus, which is not equal to lambda 0 of H2. So option B is wrong. So what is the next one? So we did a extensive problem last class, like how to calculate the equivalent conductance of sodium. Sorry, what was that? Acetic acid. We have given with equivalent conductance of sodium acetate, HCl, I think KCl, so K2SO4 and Na2SO4, etc. Like that. So it is simplified version of that. So what is the option C? Lambda 0 HNO3 plus lambda 0 NaOH minus lambda 0 Na. This is the same way data. No. NaNO3. How can I write it? It can be written as L0. All of you parallelly try to do that. Plus NO3 minus plus L0 Na plus L0 OH minus L0 Na minus L0 NO3 minus cancels out, Na plus cancels out, which is equal to OH minus, which is lambda 0 H2. So this option is also correct. So what is the next option? D is lambda 0 NH4OH plus lambda 0 HCl minus lambda 0 NH4Cl. How can I write it? L0 NH4 plus L0 OH minus plus L0 Cl minus L0 NH4 plus minus L0 Cl minus. So Cl minus cancels out, NH4 plus cancels out, which is equal to L0 OH minus plus. So this option is also correct. So for a weak electrolyte, we can use a combination of strong electrolytes to calculate the equivalent conductance. So this is a similar exercise like problem. So hope everyone understood how to write it and break it down. So we'll move on to next question. Yeah. The 298 Kelvin is 15.2 Siemens centimeter square per gram equivalent. With addition of 500 ml water, the equivalent tense. What happens to equivalent conductance? We have seen this problem. I think we have seen in practice itself this problem. So how can I equivalent conductance? Lambda is equal to 1000 L by C. Lambda is proportional to 1 by C. So as we dilute, what happens? Lambda increases. So that's the answer. So last question for last week's homework. So question is, go to next page. The resistance of zero point 0.1 normal solution of NaCl placed between platinum electrode 1.5 centimeter apart and 6.8 centimeter square area was found to be, what is the value? 23 ohm. 23 ohm. Calculate the equivalent conductance. Can you solve this and tell me the answer? What's the answer coming? We have to find what is the value of lambda. What's the formula for lambda? Lambda is equal to, what is the formula for lambda? No, we have to find equivalent conductance. So that value is correct. That is specific conductance. Whatever you commented is specific conductance. From that, we have to find out equivalent conductance. So equivalent conductance is nothing but 1000 L by C. So in this portion, I will say no need to remember any formula. Only one thing you remember, R is equal to rho L by A. We have conductance capital gamma is equal to lambda. Capital lambda is equal to 1 by R. Where similarly we have capital L, which is nothing but specific conductance, which is 1 by rho. So how can I write? I'll just take the inverse. So reciprocal will get is equal to L into A by L. So from that, I want L value for calculating lambda. So I can write L is equal to delta into L by A. So from this I can we have value of R. So capital lambda is equal to 1 by 23, which is nothing but 0.0435 unit is Siemens, or you can write mho. Then we'll substitute here L is equal to 0.0435 into L is 1.5, area is 6.8, which is nothing but, right in the next page, which is nothing but which is equal to 9.5 596 into 10 raised to minus 3 Siemens centimeter inverse. So just I need to substitute here. So lambda is equal to 1000 into 9.596 into 10 raised to minus 3 divided by 0.1. So the answer will be 95.96 Siemens centimeter square per gram equivalent. Fine. Shall we move on? So finish here last week's content. So this week what we have seen. So I haven't discussed a little. Yeah, that's the answer. 95.9. I got 96. That's fine. So for gram equivalent. So you have to read the question carefully. So in this kind of questions, these are very easy. Only you have to remember R is equal to rho L by A. Then you have to remember the relations. Then just to take reciprocal to get the other quantities. So this also you have to just remember how the equivalent conductance can be calculated. If C is in molarity, molar, 1 molar, zero point 0.1 molar, etc., you will directly get it in the unit of Siemens centimeter square per mole. So like that you will get. So that's fine. It's direct questions. So last week we have seen activities in electrolyte solution. So what happens is the solution of strong electrolyte mostly they will vary very much from the ideality. If infinite dilution only, the activity can be replaced by concentration. That is, activity coefficient can be equated to 1. So we'll consider a reaction AX. I won't be deriving it fully, but I'll just go through the important equations which we may be needed to solve the problems. AX by is giving x a raised to z plus y b raised to z minus. Here a plus comma a minus are the activity of cation and anion. Then we will define two more quantities. One is a plus minus, which is given by mean ionic activity, and another term is a, which is mean activity of electrolyte solution. So we'll try to find mm, the relationships. I will just define the relations. So we'll the first thing is we'll write A is equal to, that is mean activity of the electrolyte solution can be written as A plus minus, which is nothing but mean ionic activity raised to gamma, raised to not gamma, raised to nu, where nu is equal to x plus y. Similarly, A plus minus raised to gamma you can write equal to A plus raised to x, A minus raised to y, where A plus minus you can write nu square root of a plus raised to x, a minus raised to y. Now let's introduce the term of activity coefficient. Activity coefficient, which is nothing given by f. So similar terms, f plus, f minus, then f plus minus and f. Those things. As we all know, activity is nothing but it is activity coefficient into concentration. So here you can write A is equal to I'll just write the before terms also. A plus is nothing but, sorry, A plus is equal to C plus into F plus. Then A minus is equal to C minus into F minus. A plus minus is equal to C plus minus plus minus. So this general relation, we can derive the expression A is equal to A plus minus raised to nu, which is nothing but C plus minus F plus minus whole raised to nu. So again, C plus is can be written as x into C, and C minus can be written as y into C. So substituting this, A is equal to x raised to x, y raised to y into C raised to nu, f plus minus raised to nu. So these kind of relations you will be seeing. So mostly in homework problems, I haven't seen any direct questions from this. So we can simplify, and I don't know whether exams will ask this derivation. So better practice once or twice. It is straightforward. You have to remember the sequence and do that. So the next term we have seen is ionic strength and its importance. So here, for a infinite dilute solution, we can write gamma plus minus is equal to 1. So gamma plus minus is nothing but gamma. We haven't seen gamma term, so gamma is nothing but activity coefficient in terms of molarity. So we have a plus is equal to gamma plus m plus. Similarly, a minus is equal to gamma minus m minus. So like that we have. So when we plot gamma plus minus versus concentration, which is in molarity. So if we, maximum value is 1. So for suppose it is HCl, NaCl, and KCl. So we can see that these all are similar type of salts which all shows a similar trend in the plot of gamma plus minus versus concentration. When we plot the plot of CaCl2, the plot shows a different behavior. So what here is for similar type of salt, it will follow one behavior, and different kind of salt, it will be having a different behavior. So from this, an empirical relation has been derived. What is that relation? Ln gamma plus minus is equal to minus A1 root concentration. Concentration here is in molar unit. This is a constant. So this kind of relation has been derived. So now we'll come to, so hence we can write gamma plus minus depends upon total concentration of ions as well as the nature. Nature here we will say, we can say by nature here is Ca2 plus, whereas here H plus, Na plus. So it is nothing but the charge. That is the gamma plus minus will be depending upon total concentration as well as the charge or nature of the individual ions. Hence, a new term has been introduced by Louis Randall. Louis Randall. What is nothing but I, which is ionic strength. So ionic strength I is equal to half into M1 C M1 set 1 plus M1 set 1 square, M2 set 2 square plus etc. So we'll take an example of example where Mi is equal to, this Mi is nothing but the molarity of ith ion. Set I is the charge on each ion. Suppose we take Mi is equal to 0.008 of a mixture of BaCl2 and KCl. So in this case, we can write I is equal to into 0.008 into 0.008 into 2 square plus 0.008 into 1 square plus 0.008 into 1 square plus into 1 square. So the value will be, here ionic strength will be 0.029. So this is the example given in the class. So this is the new term introduced by Lewis and Randall. Yeah, you are asking something? Okay, by mistake, I think I mute it. Hello. Two people are asking. Can one of you mute and ask? Santosh. I think Ashwin was asking Santosh. But if by mistake, unmuted. Yeah, one of you have to mute. I can't hear. Yeah, yeah, fine. Santosh, are you asking something? Yeah, Ashwin can ask now. Hmm. So, listen one thing. The questions are clearly given by NPTEL team. My purpose is just to solve some problem which will help you to solve the homeworks. So here, I think you have joined late, right? I don't know. In the starting, I have, even though I solved all the assignment six questions, all the five questions I have solved at the starting. Hmm. 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 Okay. Hmm. Okay. Hmm. You listen, this thing, I cannot do anything because the question and answer are given by Professor Asdosh from ISER Mohali. Hmm. Hmm. Okay. So, yeah, yeah, I don't have any direct relation with him, but I can write to the TA. Yeah, like I understood your point because in homework, I think five or not, for the calculation of transport number or something, there was a missing, like electrolyte solution term was missing. So there are some mistake like that. So as far as I can do, when I'm solving it again, the next class I can try to solve it. If it is not, I'm not getting the solution means I can also write to the faculty. Like there are some typos as well. I think you have attended. Have you attended last class? Yeah. Hmm. I don't. No, you cannot say like that. Some problems you will feel like options are not correct because I'm solving. I'm solving all the. No, I'm solving all the questions in the next class. Some problem I am also feeling. So I also agree with that. Some problems I am also feeling something is missing. But yeah, that you can have to write to the faculty. So right now, what that's not in my control actually. Like whatever questions are given in the assignments, I don't have the right to reiterate. Even you see, I'm not touching any week seven questions here because it need to be solved by the students. Once in week eight, I'll be solving week seven problems. Hmm. Hmm. Okay. Hmm. Okay. No, once one student was asking, I think Ashwin is here. So I told him to write to faculty. Did you get any response to that? One should. Hmm. Hmm. Yeah, yeah. This is. I will inform to the NPTEL team here. Beyond that, I can't do anything in this case because evaluation, nothing is on my hand. No, no, that's the thing. Faculty, you see, faculty, we are not in direct contact. We are assigned with a separate work. Like, so I'll solve some problems which will make the student little more easier to solve the homeworks. Like that problems I will formulate and do. Similar, it will be similar questions, but it won't be the same like that. Yeah. Hmm. Yeah, I'll inform to the NPTEL team this year. So you are saying, yeah, yeah, I am. You see, I am going through it. That's no, no. What you are saying, I agree. But the thing is that I'm solving it. I am getting the answer. Till now, only one question, two questions. I had problem. I am solving it every time. Like regular students, you can ask every class at the starting. We are solving the previous week question. If someone asks doubt, also we are solving it in the next class. So if any problems I am feeling, I am also expressing it. Yeah. Hmm. Yeah, yeah. Where we stopped. So we stopped at hydration. Hydration and iron mobility. So this portion we have. So the Ashwin, I will suggest you one thing. This kind of things can be discussed at the end of the class. That could have been better because the entire flow has been gone for the class. So I request you next time if you have anything like this, either at the end of the class or at the beginning before we start, you have to mention it. So that's a better way. So we were seeing hydration and ion mobility. So we have seen in the last class also, while we are solving the problems regarding transport number we have seen the ions and ionic conductivity. We have seen H plus have very high ionic conductivity, something like 349.8, and from Li plus, Na plus, K plus, Rb plus, Cs plus, we have 38.6, 50.1, 73.5, 77.8, 77.8. So we have seen an increasing trend here and we have seen a bias. What is the reason here? So I have explained in the last class why H plus have very high ionic conductivity. What is the reason? Someone we have discussed in the last class also. The property is called Grothus, Grothus Hoping mechanism. So in many cases, we have seen hydrogen evolution reaction, etc. We have H plus ions in the solution. So in aqueous solution, what happens? Oxygen, water has a structure like this where they have two lone pairs of electron. This hydrogen can make a donate this mm, and make a bond with that. At the same time, we have another water molecule beside. This can also contribute like this and make a bond here. Similarly, we have another water molecule with lone pair of electron. So it can also donate, and like this, the hydrogen can propagate. So it's like a case of lithium ion battery where we will see lithium will come out of de-intercalate from one side and it will be getting intercalated at the other side at the anode. So what happens in every case, it's not the same ion, it's going out from one and getting into the other, where it is like pushing from one side to other. So that here H plus is at one end, whereas due to the Grotthus hopping mechanism, H plus can travel faster in the solution. That's why H plus has a high ionic mobility. Where when we consider the case of Li plus K plus etc., they are always surrounded by hydration sphere. Hydration sphere. That is, they are surrounded by many water molecules. We can write LiH2O n times. As the for when we consider Li plus, it is having high charge density. So the hydration sphere associated with it is higher. So as we all know, if the molecule is bulkier, it will find difficulty to. If something is bulkier, it will find difficulty to move from one end to other. Similarly, the entire size, that is lithium plus hydration sphere, is biggest in size, so that it will find difficulty to move from one end to another. Similarly, when we go down, the size of cation plus this hydration sphere decreases so that they can move faster. So in the class, it was discussed 4 points. Uh, the movement of were the movement of ions in an electrolyte solution depends on four factors. What are the first point? First is the electric field, the electric driving force. Electric driving force, which is nothing but the potential difference, potential difference applied between two electrodes. Then second one is the hydration sphere. So when an ion is surrounded by so many water molecules, it will find difficulty to move from one end to other. So solid molecule pulls the ions back. This is called hydration sphere. Third one is the inter-ionic attraction. So in general, cations are surrounded by anions and anions are surrounded by cations. So what happens when a potential difference is applied? This positive ion and negative ions try to move towards positive ions try to move towards cathode, where it is pulled back by other ions. So the ion need to overcome this force to reach the other electrode. So what happens? The net effect is something called electrophoric effect. So I'll give a definition for that. So what is that? When an electric field is applied, for is electrophoric effect. So here when a electric field is applied, a cation migrates towards cathode and through the medium, while the negatively charged ion along with solvent molecules moves towards anode. This counter movement causes retarding influence on the movement of central ion. This effect is called electrophoric effect. This called electrophoric effect. That is, the relative velocity of ions would be less than that was expected, assuming that the solvent is static. So we'll be having a net lesser velocity than expected. So debate, we have debate. So the proposed lambda is equal to lambda 0 minus a plus b lambda 0 into root c, where a is equal to a constant which is nothing but 50.5 and b is equal to 0.224, which is applicable in water. So next we'll see just the equations for solubility and activity product, and we'll move on to the problems. So solubility and activity product. So we will consider this reaction. Consider AgCl, AgCl aqueous gives Ag plus Cl minus. As we have already seen in the third class or something, we have for equilibrium reaction delta G is equal to 0. Hence, it will be in equilibrium. So we have La is equal to activity of Ag plus into activity of Cl minus, which is nothing but Cag plus into CCl minus into F plus minus square. So for a saturated solution, we can write approximately F plus minus is equal to 1. Where it is close to ideality. So Ls is equal to Cag plus Cl minus. Yeah, sorry, 1 second. Yeah, CCl minus. So we can also write the solubility product is nothing but Cag plus is equal to Cl minus is equal to solubility, where in this case solubility product will be S square. Similarly, we have one more relation where solubility can be for a general type of this one. We can write solubility is equal to gamma root of Ls divided by x raised to x, y raised to y. So this is a general relation. You may need it for solving this week's problems. So we'll now move on completely to problems. I have 1, 2, 3, 4, 5, 8 problems. So we'll try to solve it together. So there are few problems given in the class which was unsolved. So we'll start from those questions. Question 1 is the specific conductance of 0.01 normal KCl solution is 1.225 into 10 raised to minus 3 Siemens centimeter raised to minus 1 centimeter raised to minus 1 at 18 degrees Celsius in a conductivity cell. In a conductivity cell. At 18 degrees centigrade, 18 degrees centigrade, the resistance of 0.01 normal KCl solution is found to be the one found to be 145 ohms, and that of 0.002 normal K2SO4 solution was 712 ohm. Calculate the cell constant and hence the equivalent conductance of K2SO4. So try to solve it. I'll come in a minute. Yeah, please. Excuse me. Try to solve this problem. So we can solve this. Ultimately, we have to calculate lambda. What is the formula for lambda? Lambda is equal to 1000 L by C. So here we are given L. KCl is equal to 1.225 into 10 raised to minus 3 Siemens centimeter raised to minus 1. Then another term given is resistance of KCl solution in the conductivity cell, which is nothing but 145 ohm. So how can we calculate? Can we calculate the cell constants from this? We have to calculate L by A using this. For a particular conductivity cell, L by A. What is the cell constant coming? What is the value for cell constant? What is cell constant? Anyone? How can I solve it? So we have capital lambda KCl can be written as 1 by R, which is nothing but 1 by 145, which is equal to 6.9 into 10 raised to minus 3 Siemens. So I can, we have already written R is equal to rho L by A. So I can write lambda is equal to L A by L. So I can write L is equal to lambda into L by A. So L by A is equal to L by lambda. which is nothing but 1.225. Okay, kappa. So what is kappa? Can I check the unit? No, you have to mention the units and all. Then only I will understand what is that. Okay, okay, okay. That is I am representing as L. Yeah. So L will be 1.225 into 10 raised to minus 3 divided by 6.9 into 10 raised to minus 3. So the what will be the answer for a cell constant? What will be the cell constant? Yeah, it will be 0.178 centimeter inverse. Yeah, 1.178 centimeter inverse. So we have got the cell constant. So now we can directly calculate what is the L value of BaSO4, right? So we just need to substitute lambda BaSO4 into L by A. So lambda BaSO4 you can write which is equal to 1 by 712. This value will be coming. What will be the value lambda? Lambda will be lambda BaSO4 will be equal to 1 by 1 second. Okay. So the value I haven't calculated. So we'll directly calculate L. So L BaSO4 is equal to 1 by 712 into 0.7178. 178. What will be the value? Can I change? Noted? Yeah. So the value will be coming 2.49 into 10 raised to minus 4. Always put units, Siemens, centimeter raised to minus 1. So from that we can calculate lambda is equal to 1000 L by C, which is nothing but 1000 into 2.49 into 2.49 into 10 raised to minus 4 divided by what was the concentration? 0.002. The answer will be yeah, the answer will be no, 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 no. You have messed up the unit somewhere. So somewhere the units are mixed up. I think you haven't considered the 1000. The answer will be coming 124.5 Siemens centimeter squares per gram equivalent. Molarity I haven't calculated. We have taken normality, so it will be coming per gram equivalent. Siemens centimeter squares per gram equivalent. So we move on to the next question. So this is also some problem given in the class. So first question is done. Second question. At 25 degrees centigrade, at 25 degrees centigrade, the mobility of NH4 plus and OAC minus at infinite dilution are, what is the value? 7.6 into 10 raised to minus 4 and 4.7 into 10 raised to minus 4 centimeter squares per volts per second. Calculate the equivalent conductance of NH4 or AC and and transport number of, what is that quantity? Transport number of NH4 plus ions. It's straightforward question, so we'll solve it fast. So please try to solve it. What's that? How the transport number can be calculated? TNH4 plus is nothing but U divided by U plus V. Here it's given U is equal to 7.6 into 10 raised to minus 4. What's the unit? Centimeter square. Check the unit also. Second, where V is equal to 4.7 into 10 raised to minus 4 centimeter squares per volts per second. So here T NH4 plus can be written as 7.6 divided by 7.6 plus 4.7. So I take the common 10 raised to minus 4 into 10 raised to minus 4. So the answer will be 0.618. So once T NH4 plus is given, we can write T OAC minus is equal to 1 minus T NH4 plus, which is nothing but 1 minus 0.618. 0.382, right? Yeah, 382. So now we can calculate lambda naught. Yeah. What's the formula for lambda 0? Lambda 0 is equal to, anyone? Lambda 0 is equal to UF divided by T plus. F is the Faraday constant. So we can write here, what is the value of U? 7.6 into 10 raised to minus 4 into 96485 divided by T plus, which is nothing but 618. So the answer will be coming 118.65 Siemens centimeter squares per gram equivalent. I think these all are easy problems only, but one problem is little tricky. So remaining problems are easy. We have one, two, three, four, five, six. Yeah, six problems remain. Okay. So write the next question. The specific conductance of TLBR and water are 2.16 into 10 raised to minus 4 and 0.04 into 10 raised to minus 4 Siemens centimeter raised to minus 1 at 25 degrees Celsius. The equivalent conductance of TLBR at infinite dilution is 138.2 Siemens centimeter square per gram equivalent. Find out solubility of TLBR at 25 degrees Celsius. So what we are given, we have given with specific conductance values as well as we are given with lambda 0, that is equivalent conductance at infinite dilution. So what is the relationship connecting this? The previous page, this one? Arjun, I didn't see the message, sorry. Yeah. So hope you have written this question. So what is the equation for solubility? Solubility SC is equal to, what's the formula? We are given with specific conductance as well as the equivalent conductance and infinite dilution. So how can we connect? We have solubility SC is equal to LTLBR, that is whatever our solute, TLH2O divided by lambda 0 TLBR into 1000. 1000 we have to convert it into liter, that's why. So how can we direct substitution? So what are the values? 2.16 minus 0.04 into 1000. So did I miss anything? Into 10 raised to minus 4 divided by 138.2. What will the value coming? What will be the answer? So what is the unit? Gram equivalent per liter. Yeah. The answer will be coming 1.56 into 10 raised to minus 3 gram equivalent per liter. So solubility is given in gram equivalent. What is the value? Point. Yeah, that's same, right? No, 10 raised to minus 1 difference. Geeta, you have missed one digit, I think. It is 1.53 to 10 raised to minus 2, right? So answer is 10 raised to minus 3. So you have did some mistake in multiplication. Just need to remultiply it. The answer is correct. I think 1000 or something. Zero is you just missed. Yeah, just check it. So that's easy. We have molecular weight of TLBR is equal to 284. I have taken it from internet. 287 gram per mole. So we can write the solubility as solubility is equal to 1.56 into 10 raised to minus 3 into 284.287. So which is nothing but 0.444 gram per liter. Yeah, but actually it's a gram equivalent per liter it will come. Yeah, answer is correct. 1.5653. That's fine. Because we have taken all others in gram equivalent, right? That infinite dilution, equivalent conductance and infinite dilution as well as those quantities. So unit will be little different, but it's fine. So if you take the molecular weight and multiply, you will get gram per liter. That's the thing we usually use in labs and all, right? How much maximum we can dissolve. So if it is fine, we'll move on to the next question. If you are moving faster, any of you finding difficulty, please let me know. We'll slow it down. That's fine. So feel free to tell if you are going too fast. The idea is you all need to take the calculator and solve it. So we'll solve it together and like that we'll get a feel of the homework problems. So I'll slightly move on to this week's more problems. Yeah. So the specific conductance of a saturated solution of AgCl is 1.55 into 10 raised to minus 6 Siemens centimeter raised to minus 1. And that of pure water is pure water is 4.3 into 10 raised to minus 7 Siemens centimeter raised to minus 1 at 25 degrees Celsius. In an electric field of 1 volt per centimeter, the mobility of Cl minus, you have noted Cl minus and Ag plus ions ions are, what are the values? 5.6 into 10 raised to minus 4 and 6.8 into 10 raised to minus 4 centimeters per second respectively. Now calculate the solubility. Calculate the solubility product of AgCl at 25 degrees Celsius. The question is to find out solubility product. So first we have to find the solubility, then using the solubility we have to calculate the solubility product. So you can write the question. How can we solve it? Here, you have noticed, I think, the ionic mobility is given as velocities, centimeters per second. But here it won't make a problem. I'll tell you why. So the solubility is nothing but LAgCl minus LH2O divided by lambda 0 AgCl into 1000. So we have to find out lambda naught AgCl. How can you find out lambda naught? At infinite dilution, what relation we have? Lambda 0 is equal to, what's the formula? No, you're asking something, Ashwin. Solubility is, you don't rush this much because let the others also solve. So once we are solving, we can type the answer. Yeah. So what is the formula? Lambda 0 is equal to, at a infinite dilution, we can write lambda 0 is equal to U plus V into Faraday constant. So here U is given 5.6 into 10 raised to minus 4 centimeters centimeters per second. Usually, what is the unit of ionic mobility? It is used to given as centimeters squares per volts per second. So you have to divide it by 1 volts per, what is the value? 1 volt per centimeter. So it will ultimately give you 5.6 into 10 raised to minus 4 centimeters squares per volts per second. So you just note it down because here it's a values one. So if you don't consider it also, so it will change, right? So if it is 2 volt per centimeter, you have to divide it by 2 because we had to. Yes, that's why here I just wrote it because you have to be aware of that electric field. So you remember, right, how we have derived the equation for this one. What you say? How we related. Initially, we have something like K into U plus V. Which one? Both are noted by same symbol. Yeah, that is fine. So I just written as U velocity in that term. So I don't know whether we can use another notation, but this is fine. So I just use U is equal to in the correct unit. So for that we have considered current of I. Yeah, the unit of ionic mobility is centimeters squares per volt per second. So try to, so you can use a different notation. That's fine, but try to correct the unit and see the unit and do the calculation. So we have taken current using that some derivation we have found out this K constant is equal to F. So you have to consider we have applied the electric field and using that electric field we have derived the equation and got this formula. So here you have to consider the electric field as well. So just similarly V is equal to 6.8 into 10 raised to minus 4 divided by 1 volt per centimeter. So which is nothing but same value 6.8 into 10 raised to minus 4 centimeter squares per volts per second. So now let's calculate lambda 0. Lambda 0 is equal to nothing but 6.8 plus 5.6 into 10 raised to minus 4 into 96485. What's the value? Lambda 0. Yeah, please calculate. Now, what is the value of lambda 0? Yeah, lambda 0 is coming 119.64 Siemens centimeter squares per gram equivalent. Yeah. From that, we can find that what is solubility. S is equal to 1.55 into 10 raised to minus 6 minus 0.43 into 10 raised to minus 6 divided by 119.64 into 1000, which is nothing but what is what is the answer? This already someone posted 9.36 into 10 raised to minus 6 gram equivalent per liter. Won't be mole because we have taken the lambda 0 in gram equivalent. Since it is AgCl, if you take moles or gram equivalent, it won't make any difference. But if you take something like CuSO4, etc., it will differ. Its equivalent weight and molecular weight are different. So here we have molecular weight of AgCl is equal to 143.32 gram per mole. So we can write S is equal to 9.36 into 10 raised to minus 6 into 143.32, which is equal to 1.342 into 10 raised to minus 3 gram per liter. Here are solubility product. Solubility product is equal to S square. Since we have Ag plus and Cl minus, we can write as S square, which is nothing but 1.8 into 10 raised to minus 6 gram per liter square. Is it fine? To the next question. It's a short question. Yeah, you haven't noticed that we have multiplied by molecular weight, right? Which one you are asking? How it will come 10 raised to minus 6? Because 9.36 into 10 raised to minus 6 into 143.32. Yeah, yeah. No, no, Ashwin was asking how it is gram equivalent per liter here. So, because we have multiplied by 1000, that's why we are converting that centimeter. The units were in centimeter cube. So, we multiplied it and the lambda 0 is AgCl is coming in Siemens centimeter square per gram equivalent. So, it will directly come like that. So, the 1000 is actually a conversion factor. Mole per liter is the unit for molarity. So, for converting that, we are using that 1000. Fine. Yeah, gram equivalent you see here, lambda 0 is equal to 119.64 Siemens centimeter square per gram equivalent. So that will directly go to top. That's it. Yeah, fine. So I suggest if we have any doubt in unit, let's do it in that way also. Whenever we are writing, we'll write Siemens centimeter raised to minus 1 divided by Siemens. Yeah, that's fine. Yeah, gram per liter also will write. So we can convert it easily. You can convert it, right? Yeah. Next question is the specific conductance of saturated solution of AgCl is found to be 1.86 into 10 raised to minus 6 Siemens centimeter raised to minus 1, and that of pure water is 6 into 10 raised to minus 8 Siemens centimeter raised to minus 1. the solubility, the solubility of AgCl given lambda 0 AgCl is equal to 137.2 Riemann centimeter squares per gram equivalent. So it's direct. So I will do that. S is equal to L AgCl minus LH2 divided by lambda 0 AgC, which is nothing but 1.86 minus 0.06 into 10 raised to minus 6 into 1000, sorry, into 1000 divided by 137.2. What will be the answer? The answer will be 1.312 into 10 raised to minus 5 gram equivalent per liter. We'll just write the next question. So I'll just ask the pencils. Yeah. Question is, next question, the conductivities of water and saturated solution of spare, sparingly soluble AB2 are 7 and 21 microsiemens per meter respectively. Given lambda 0 A 2 plus is equal to 12.72 millisiemens meter squares mole raised to minus 1, and lambda 0 P is equal to 7.64 millisiemens meter squares mole raised to minus 1. The solubility of AB2 in moles per meter cube is what? So the question is, we have to calculate solubility of AB2. AB2 is a specific type of CaCl2, etc. You can imagine AB2. We have to calculate solubility of that in water. The unit should be in mole per meter cube. So can you all try to solve this problem? Able to solve this? So what's the formula for solubility? Your answer is something different. Yeah, this is some type of multivalent salt only. Yeah, we have questions like that, don't worry. Yeah. So how can we solve it? We have the S is equal to what is that? LAB2 minus LH2O divided by lambda 0 AB2 into 1000. This is the formula value. So what we have to find out the value of LAB2 as well as which is equal to 21 microsiemens per meter and LH2O which is 7 microsiemens per meter. So these values are given. We have to find out lambda A, B, 2. Yeah, Ashwin, you came closer. So it will be millimolar, 0.5 millimolar. So you just need to check the unit. So how can we calculate lambda AB2? So what is the reaction here? AB2 will be giving A2 plus 2B minus, right? So I can write lambda A plus 2 into lambda B minus A2 plus. Yeah. So which can be written as 12.72 plus 2 into 7.64. So which is uh, 12.72 plus 15.28, which is nothing but 28 millisiemens meter squares per mole. Once the value is got, we can write S is equal to 21 minus 7 into 10 raised to minus 6. I am converting to Siemens divided by 28 into 10 raised to minus 3. Here also I am converting it to Siemens. So here Siemens per meter. Here Siemens meter square per mole into 1000. 1000 here, sorry, here 1000 I don't need to put because I have to calculate it in meter itself. 1000 is not required, sorry. 1000 is not required because when we need to do calculations in liter, we will convert centimeter cube to liter using that 1000. Here we don't need that 1000. So what will be the answer here? It will be directly coming here. So I put here 1000 also. So no need of 1000. Yeah, what will be the answer? So how you are getting? Yeah, the answer will be 0.5 into 10 raised to minus 3 mole per meter cube. I'll write it as 5 into 10 raised to minus 4 mole per meter cube. Just recheck the units. Direct substitution. You have to convert it into everything to Siemens because one unit is given as micro Siemens, another one is milli Siemens. So there is a 10 raised to 3 order of magnitude difference. So solve a little longer problem and stop this class. So the last question for this class will be the the conductivity of 0.001 molar Na2SO4 solution is 2.6 into 10 raised to minus 4 Siemens centimeter raised to minus 1 and increases to 7 into 10 raised to minus 4 Siemens centimeter raised to minus 1 when the solution is saturated with CaSO4. The molar conductivity of Na plus and Ca2 plus are 50 and 120 Siemens centimeter square per mole respectively. Neglect the conductivity of water. Find the solubility product of CaSO4. So can we solve that? So let's just start this. This is little conception. So anyone got the answer? Conductivity of what's given? Na2SO4 is given. Na2SO4, which is nothing but LNA2SO4, which is equal to 2.6 into 10 raised to minus 4 Siemens centimeter raised to minus 4. So here we can calculate lambda Na2SO4 is equal to 1000 L by C. So C is nothing but the solubility. So that is molarity. So 1000 into 2.6 into 10 raised to minus 4 divided by concentration is 0.001, which is equal to 260 Siemens centimeter squares per mole. So we have want to find out lambda Na2SO4 is equal to lambda 2 lambda Na plus lambda SO4 2 minus. So we can write lambda SO4 2 minus is equal to lambda Na2 SO4 minus 2 lambda Na plus Na plus lambda is given 50, so we can write it is equal to 260 minus 2 into 50, which is equal to what is the value coming? 160 Siemens centimeter squares per mole. So we got lambda 0. Hmm. The equivalent conductance, not lambda 0, it's not saturated. Equivalent conductance of sulfate ions we calculated because we have given with equivalent conductance or conductivity or molar conductivity of not equivalent molar conductivity of Na plus. So from the total conductivity of Na2SO4 and conductivity of Na plus we have calculated what is the conductivity of SO4 2 minus. So conductivity of CaSO4, similarly we can write the total conductivity is given by what is the value 7 to 7, right? The total conductivity is 7 at saturation. Then we have conductivity of Na2SO4. From that we can find out what is the conductivity of CaSO4. We are considering the conductivity of water is negligible. So we can write 7 minus 2.6 into 10 raised to minus 4, which is equal to 4.4, right, into 10 raised to minus 4 Siemens centimeter raised to minus 1. So similar problems, what I am doing is I am taking it from some internet sources. Then whatever problem solving last year's problem like that I am taking. So one thing you can do, let me try. I'll just go through a book. Puri and Sharma, there is a chemistry textbook. So it is a physical chemistry textbook. So it has some problems. I think Atkins also. There is one textbook called Atkins. It also has some problems on this. I'll check and where I could. Uh, so I'll in the discussion for or you can note down my email ID. Sorry to go in between. So I'll give my email ID after this program. You can mail your email ID. So I'll try to share some reference textbooks sources. I cannot share the textbook, but I can suggest some textbook. I'll ask some physical chemistry students also. Then I'll share some appropriate textbooks. So we have calculated the conductivity. So lambda Ca SO4 is equal to lambda Ca plus lambda SO4 2 minus, which is equal to 120, which is given in the question. So for Ca plus equivalent, the molar conductivity is 120. So 120 plus for SO4 minus it is 160. So which will be equal to 280 Siemens centimeter raised to centimeter squares per mole. So once we calculate, we can directly calculate solubility. Solubility S is equal to 1000 L by lambda CaSO4. So which is nothing but 1000 into 4.4 into 10 raised to minus 4 divided by 280. The answer will be 1.57 into 10 raised to minus 3 mole per liter. So the question is to find out. So I'll just fasten it up because I have to leave another meeting at 8. LS, the question is to find out the solubility product. LS is equal to concentration of Ca2 plus into concentration of SO4 2 minus. Here you can see the in the question SO4 2 minus are coming in two parts. In Na2SO4 also SO4 2 minus is there, as well as when we look at the next one, where is it? Yeah, CaSO4 also SO4 is there. So in this case, you have to take SO4 2 minus total. So for that, we will do, which is equal to 1.57 into 10 raised to minus 3 into 1.57 into 10 raised to minus 3 plus 0.001, which is nothing but the molarity of Na2SO4. In that 0.001 molar sulfate is also there. So which is nothing but 4 into 10 raised to minus 6 molar cube. I'll just give a hint also. So for multivalent problem, we have calculated how the while doing this is just a hint. So we have equated two things, right? So while solving problem, please consider also for multivalent ions, you have to consider one more point. Where is it? So I'll just check where is it? Yeah, right means here. While we have seen some formula like L0C is equal to K1 N plus Z plus E into U, where L0A is equal to K2 N minus Z minus into E into V, right? So for charge neutrality, we have taken these these terms to be equal, but we have considered monovalent. So the set value will change for monovalent and multivalent. So while doing a problem, please, if it is a multivalent, please take the number for set plus and set minus carefully so that you won't make a mistake in the problem. Fine. So that's all for today. I have one more two problems. I think in the next class starting, I'll solve that problem and come and we will go forward. Don't worry, next class we'll try to. Anyway, Ashwin suggested something. I'll write to the NPTEL team. So we also seen in assignment 2 and assignment 5 there are small mistakes. So I'll also this time write to the NPTEL team. If there are any mistake in the this year's assignment, I'll suggest them to correct those. So let me go through assignment 7 also. If there is any mistakes, I will also feel I'll write to them. So thanks for joining today. You are telling about H0C and H0A, right? Is it? Let me. Hmm. Yeah, let me see the problems. I actually week 7 problems I haven't seen. I'll check it. I'll try to check it before Wednesday itself. I'll write to the NPTEL team accordingly. Because last I can't see that actually because I'm not a registered student. Yeah. Yeah, let me check. No problem. I'll write to them if any mistakes. I'll try to solve it today or tomorrow. Yeah. Question. Question 7. Okay, okay. This year's assignment, right? Okay, let me see. Yeah, fine. Thank you. I'll wind up this today's class. We'll further discuss in the next class. Thank you, everyone.